Let me introduce you to DR.DRO. A viewer named Stefano reached out to me and asked if I wanted a sample of a DRO system that he's working on developing. You might have seen the video that Rotary SMP did with him, but he sent me one and I'm going to set it up and try to get it on my lathe and show you why this is a lot more than just a normal DRO. I got some cheap Chinese scales off of eBay. He said that sometimes you have to repin them, but mine worked right out of the box. You'll notice this has X, Y, Z, and A, and I have this rotary encoder that I want to hook up to A. Luckily, the wires on the encoder are labeled on here. Brown wants 5 volts. That goes in pin 1. Blue is 0 volts. That goes in pin 2. The shield can go on the ground. The encoder outputs go on 3 and 4. Those also need pull-up resistors back to the 5 volt. This encoder has a Z channel output, but that's not going to get used here, so it's just kind of flopping around. So now we have rotary encoding as well. What makes this thing really different from a normal DRO is inside here where we have connections for a stepper motor driver. The Pulse Plus, Direction Plus, and Enable Plus pins all share a common wire. That's on the plus terminal on this end. And then the minus sides come into these pins, Enable, Direction, and Pulse. So I have absolutely none of this calibrated yet, but now I can index the stepper motor. But the really cool part is you could use your encoder to control the stepper motor. Even cooler than that, though, you can also use the linear scales to control the stepper motor. Let's go put this thing on the lathe. Off camera, I mounted the long scale on the bed and the reed head on the carriage, just like everybody else does in every other DRO video on YouTube. I actually used the existing holes here, mounted a spacer, and then mounted the reed head to that, so I didn't even have to drill any holes in the carriage. So now I've got a readout on my Z-axis, or if you want, Z-axis. Mildly pedantic thing. If you want to really be correct, the Z-axis is parallel to the spindle, and this is X, not X and Y. You live your life how you want, I'm doing it that way. I did check it with my massive 4-inch indicator, and it's right, so that's cool. Now we hit on the one that's always a challenge on these small lathes, which is where the heck do I put this? If I put it there, it's obviously not going to fit under the cross slide, and I wouldn't be able to use my follow rest. If I put it there, it gets in the way of the chuck. So I think, and I'm going to credit Ollie's workshop with this idea, is put it back here and make an extension that picks up the reed head. And I do have, a good finger width of space under this cover and above the lead screw. What is that? 600 thousandths? Yeah, it's about that. We'll go 5/8. Could probably go, we can go 3/4 there. That lead screw's showing its age. Kind of looks like probably more content. Problem is, of course, this is rough cast and tapered. This is rough cast. There's not a machined surface on here to make sure that it's parallel. Found a piece of stock that's 5/8 by 3/4, convenient, and I'm going to put it right there. This has ever so slight dish or crown to it, and I want to flatten that out. This is already pretty thin, so I want to keep the amount of material I remove to a minimum. I am binding up a little bit on that lead screw, so I'll need to machine out a little bit there. But I think something like that, put that there, Now I need a bracket here. I've got this really disgusting piece of cast iron. I think there's a bracket in there. Well, I guess I hadn't really planned on disassembling the entire carriage, but things escalate quickly, and now I've got the saddle all stripped down and trimmed in on the mill table. That way I can make a flat spot here. Well, that should keep everything out of the way pretty well. You know, I've really only reduced my swing over the carriage by a button head screw. I can still get my tailstock all the way up there. One of the big things is on this lathe, the follow rest mounts right here. So I still have that. I still need to figure out if I can mount this guard on here. I think it's just going to get in the way. I guess if I go like that, I don't know that that's really going to gain me a whole lot, since stuff's still going to be shooting in that way. Anyway, let's put a big indicator on here and see if it actually works. Zero that. 100 looks good. So over 2.3 inches and 4/10,000ths off. I think I'll take that. But this is reading the wrong way. I want positive to be out, so I'm going to go to Settings, Scale 0, it's the x-axis. I'm actually going to change this to -5. It's -5 because these are 5 micron scales. And then exit, and now it should, if we 0, we should move in. So that's right. But right now it's reading on radius. Of course, on a lathe, it probably makes more sense if this reads on diameter rather than radius. So what we'll do is go in, instead of -5, make this -10. So now if we 0 this and go 100,000ths here, we should see our diameter change by 200,000ths. And indeed it does. And now I need to remove the reversing switch. I never really liked having it here anyway, since it kind of involves reaching across the workpiece. There are 2 threaded holes on this pulley cover. I think this might be where the reverse switch originally mounted. Found a piece of scrap, just drilled some holes in it. So it's inevitably going to come up that you shouldn't use a reversing switch on a lathe with a threaded spindle, because you'll spin the chuck off. But if you want to do metric threads, you need to keep the half nut engaged and run the carriage back out under power. And the other thing I use it for is if I'm backing a tap out. That's it. And in those cases, you don't really have to worry about the chuck falling off. Normally I start and stop the lathe with the switch that's down here. One other thing that makes absolutely no difference to you, dear viewer, is I used to have this set up so that way was forward. Now I have it that way is forward. And that's so I can open the lid to change speeds without having to mess with the switch. I guess you could argue that having to turn this off is in a way a safety feature. But the thing about this lathe is as soon as you open the lid, it detensions this belt. So even if it is on, it doesn't really do anything. Well, I thought I had that reversed. Huh. I guess we'll just call that a safety feature. And a shout out to those of you that have already left a comment saying I should flip this scale over to keep the chips out of it. That's a good idea. Let's make a mount for that stepper motor. Oh, that's weird. I guess that was a little too much. So I need to turn down part of this screw, kind of make it match the original stud that held the gears. I'm just going to use a parting blade. I've got it touched off there. I need to go over 1.3 inches, but I need to account for the thickness of that blade. So I just go in here, touch this, say 0.125 inches. We'll dial right into 1 inch. We are at 408. So that is saying just a hair under 374, and so is that. Overall length I want 0.13. And I did that offset the wrong way. When I offset on this side, it should have been negative 0.125. There's a learning curve with everything, I guess. I made another one to the proper length and then threaded it for 3/8 so I can use the original square nut on there. Well, it seems as though the innie bit was trying to occupy the same space as the outie bit. So I made another one that just has the outie bit a little bigger. Alright, so lots changed in the last 3 seconds. I have everything mounted here. I went ahead and did it off camera because it's basically more of the same operations. Same style little arbor to mount a gear on the encoder. Went to a smaller gear down here, had to drill some more holes. So if we watch the spindle here, when I turn this by hand, go 1 rotation, you can see it's 1. So the encoder's working properly and calibrated. And if we set the stepper motor to follow the spindle, the lead screw moves. So I'm not going to go into how to calibrate and set all those ratios right now, because one thing you need to understand about this is this system is still very much in testing, very much in development, and the way we're doing it now is going to change. The electronic lead screw functions are not fully implemented yet, but it's enough that we can test it and prove out the proof of concept on it. One other thing I want to mention, because I know you're thinking it, is I should have used timing belts here, because this has way too much backlash to ever work. But the thing to keep in mind is that that backlash, or most of it, has been in this lathe for 80 years. I'm using the original components. Any backlash that was here was still driving that lead screw. And it doesn't matter because the spindle is almost always spinning in the same direction, and certainly spinning in the same direction when it matters. For better or worse, I still get all the glorious gear noise from this lathe. And when I close this cover, you'd really never know. I've got my typical crusty, slightly bent piece of mystery steel here. Right now this is set up so this is basically threads per inch. We're going to go 200, which will give us 5 thousandths feed per revolution. Again, I think I've mentioned it, but all of this is going to change. We'll turn that on. Well, that was wrong. Did I mention this is going to change? So I just realized because the encoder is hiding past the reverse lever here, I can still use the original reverse lever to change the direction of the lead screw. That amuses me. Well, the good news is I'm able to lug the spindle motor down before the stepper bogs out, so it seems like that thing has enough torque. Let's do a thread, and we're not going to fool around. We're going to do 4 TPI, which should be 2. I got that backwards. That should be a half, but actually we need to go 5. Again, all of this is going to change. I cut that to half the depth for a 4 TPI thread because I'm going to make this into a 2-start thread. So if I go in here for the indexing, I have it set to 4 divisions, and I'm going to go 2. And we should be offset halfway now. So I didn't understand that right. It's actually 1 full turn of the lead screw. Well, that's definitely a 2-start thread, and I'll say it's not a very good one. The peaks should all be even, and they're not. I could tell the indexing was working right. As I was cutting the last few cuts, I went back and forth between the 2 positions, and I could tell it was trying to cut on either side of that higher ridge. So I was trying to get it right. Just to test it, I did just a scratch pass with all the same settings. And that came out exactly how it should. Part of it's my fault too. I was running faster than I should have, trying to push it a little bit to see what it would do. Crashed it a few times, my fault. That's pretty neat, but that's not really what I'm excited about this thing. Let me show you something else. Instead of setting this to track off of the spindle, we're going to set to track it off of the carriage. Then we can engage our cross feed. So when we move the carriage, it'll feed the cross feed in and out. So what that means is with the proper ratio set, we can turn tapers with it. Obviously hand feeding is never great for surface finish, but I think I could get it better than that if I really tried. I also made that a little too long. Let's go ahead and do the Sharpie thing. Let's see how well we can get this thing stuck on here. Yep, that's stuck on there. Obviously not perfect contact. Part of that's probably my worn tailstock, but got some bands pretty much everywhere along there. I think if I grind a tool with a large nose radius, I can get better surface finish on there, get rid of some of that. I feel like I kind of glossed over that because, well, the camera battery died right when I started filming the main taper turning. But if you've ever spent a really long time bumping your compound around with an indicator to get a taper set, you'll know how freaking cool it is to be able to do it with just the push of a button. I hope it's obvious that what I did here was really kind of quick and dirty proof of concept type stuff. It's very much just beta testing to see if this works the way it should. And so far I would say that it does. I've got the honor of being the first person to really try out this system on a lathe, and I know Stefano has a bunch of updates he's working on right now to make the user interface more friendly and to just make the system work better overall. Once I've got that update and I spent some more time with this getting to know it a little better, I think I'm going to come back and do another video to demonstrate doing some taper tooling for my milling machine. I think that'll be pretty good. I'm really excited to see where this project goes. I think this is going to be a really powerful tool. I want to say thank you to Stefano for reaching out to me, sending me this thing, helping me get it set up, and including me in the testing process of it. Also, a shout out to Anchor Lube for their continued support of the channel, and my patrons and YouTube members for their support. And thank you for watching, and if you want to see what else I can do with this thing, stick around.